So here's another little mini tutorial, and this seems to be the question kids are having the most trouble with. This is from a cliff at an angle. And the reason you're having the most trouble with it is it's the toughest. It's the toughest. It is. So I made up a question here. Once again, I'm going to walk through one with you, and then I'm going to do another one that you can copy out, press pause, and try yourself. Although if you want to, you can press pause on the video right now. Try solving this right now, for that matter. So if you want to, press pause, try copying this onto a piece of paper, and I'm going to walk you through it. Okay, here we go. To me, key idea here, key concepts here, angle, I'm going to go components. And they gave me a vertical displacement, so I'm going to find time vertically. If they'd given me a horizontal displacement, the range, I would find time horizontally, which is way easier, by the way. This one is going to involve the quadratic formula. So it says, find the range. Okay. First thing I'm going to do is I'm going to break this up into its components. Let's draw it right here. I have an initial velocity of 36. I have an angle of 51 degrees, and I want to find Vx and Vy initial. So we did this, and we noticed that Vy initial ended up being sine. It ended up being the velocity times the sine of the angle. And if you don't believe me, hey, it's opposite hypotenuse, and that's why it's sine. And Vx ended up being the velocity times the cosine of the angle. And if you don't believe me, it's because it's adjacent over hypotenuse. So here we go. I would once again bring my t-table out. I'll go ax equals 0, ay equals negative 9.8. I'll go Vx equals, let's see, what is 36 cos 51? 22.656, I guess. Make sure I didn't make a typo there. 36, angle 51, yeah, that looks good. Vy, 36 sine 51, 27.978. Oh, and I know dy is, careful, negative 84. It looks like in the vertical column, that's where I have 3 pieces of information. So I'm going to find time. How? 2 possible methods. Method 1 is going to be use the quadratic formula. D equals VIT plus a half AT squared. Negative 84 equals 27.978 T. And then if you plug in the negative 9.8 right there, half of negative 9.8 is minus 4.9 T squared. What kind of an equation is this? It's a quadratic. How do I know? It's got a squared. How do I solve a quadratic? Got to make it equal to 0. I'm going to move both of these to this side by minusing that one and plussing that one, because I hate my quadratic term, the squared term, to be negative. So I'm going to solve 4.9 T squared minus 27.978 minus 84 equals 0. What is the quadratic formula? Now, I'm going to do this the long way. If you have a quadratic solver, go right ahead. I don't care. I'm good with that. But it's going to be T equals negative B, which is going to be positive 27.978, plus or minus the square root of negative 27.978 squared minus 4 times A times C all over 2A. I always do the discriminant, what's inside the square root, first. Bracket negative 27.978 squared minus 4 times 4.9 times negative 84. That's what's inside the square root. This is going to be t equals 27.978 plus or minus the square root of 2429.2. Heck, 2429.17. All over 9.8. It's going to be bracket 27.978 plus the square root of 2429.17, close bracket, off the square root, close bracket for the top, divided by 9.8. 7.884. And then if you redo it with the minus, I think you're going to get a negative time, which I ignore. Could also have used a solver. Now I do have a solver on this calculator. So if I use the solver, it would look like this. Menu equation, polynomial, degree 2. I would say A is 4.9. I would say B is negative 27.978. I would say C is negative 84, and if I'm lucky, when I hit solve, I get 7.884 seconds. Woohoo! I do. The other method you can use is if you're not happy with the quadratic formula, you could find by going Vy final squared equals Vy initial squared plus 2AD. How to get rid of a squared? Square root. It would be the square root of what was Vy initial. It was 27.978 minus, plus 2 negative 9.8 negative 84. And if you do that, oh, squared, Mr. Dueck, sheesh, almost forgot the squared. If you do that, you'll get 27.978 squared plus 2 times negative 9.8 times negative 84. And you'll notice I get the same thing here that I got in the square root in my quadratic. That's because you're sort of doing the quadratic equation in disguise. Square root. Here's V final. The only problem is Vy final is negative because it's heading down. So although I got an answer of 49.29, I'm going to call it negative 49.29. And then I can solve for t by going V final minus V initial over A. But everything has to be from the vertical side. Negative 49.29 minus 27.978 all over negative 9.8. And this should also give me, I hope, 7.884. Let's see. Minus 27.978 divided by negative 9.8. And ha 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 ha. There we go. All that work, we're really not done. Because the question didn't say find time. The question said find the range. Well, thankfully, we're done the hard part. The range is the easy part. The range is horizontal, and it's going to be except A is 0, so it's just going to be Vxt. I found T, 7.884. What was Vx? 22.656. It's going to be 22.656 times 7.884. What did I say? It was 26.65? Yeah, that's right. Okay. 22.656. I think I said 26. 22.656 times. My range is going to be 179 meters. Wow. Okay. There's off of a cliff at an angle. I'm going to give you one to practice. So here's the practice question. Cliff at an angle. Suppose the launch angle is 31 degrees. The initial velocity is 96 meters per second. And the cliff is 112 meters high. Find the range. So pause the video, copy this question out, try solving it, and then press play and see if we end up with the same thing. Okay, hopefully by now you paused the video and copied it out and are now checking your solution. If not, pause the video. Anyways, here we go. I'm going to take some shortcuts and because I'm in a rush, but I would go like this. Horizontal, vertical. I would say to myself, okay, I better draw little pictures. So the velocity is 96 meters per second. Angle is 31 degrees. Cool. Here's Vx, here's Vy initial. Ax is 0, Ay is negative 9.8. Vx is going to be 96 cos 31. $82.288. Vy initial is going to be 96 sine 31. $49.444. They gave me a vertical displacement. It's negative 112 meters. I'm going to find time. I'm going to choose to use the quadratic formula method. If I use the quadratic formula, I'll get d equals VIT plus a half AT squared. I'll get negative 112 equals 49.444t minus 4.9t squared. I'll get 4.9t squared minus 49.444t plus 112 equals 0. And now I'm going to cheat and go to my quadratic solver. Repeat. That's still 4.9. Negative 49.444 and positive 112. Nope, not positive, Mr. Dueck. You solved your equation wrong. It was negative because you moved everything to that side. So this would stay negative. Sheesh. Thank goodness I caught that. And I get 11.996 seconds, almost exactly 12 seconds. 11.996 seconds. Now, if you wanted to use the V final method, you should find that Vy final ends up being Vy initial squared plus 2AD. It ends up being this number squared plus 2 times negative 9.8 times negative 112 square root, and then make it negative, so negative 61.11, negative 68, sorry, 0.12, negative 68.12, and that should give you time equals V final minus V initial over A, which is going to give you bracket negative answer button minus V initial 49.444 close bracket divided by negative 9.8, and hopefully I get the same time value as before, 11.996. Whichever approach you use is fine, but we're not done. They wanted the range. $82.288 times 11.996 $987 Wow, that's a launch. 987 meters. So if you got that, woohoo, you're going to see one of those on your test. Again, if you need more practice, I think there's some of these in the practice test that I gave you. There's some of these in the big review, or see me.